Hello students, welcome back. Territory Rush is pretty much complete. I think at this point, all we need to do is make the game a little bit more engaging for us to play. And the way that we're going to do that is by implementing some visual game polish. So in this video, we'll add a few visual systems that just make the game overall look better and feel better as we play it. And we're going to do three systems here. The first system that we'll make is a particle system. So anytime we destroy an enemy, their little cells will explode into a bunch of particles that shoot out all over the screen. So that's going to be visual system one. Our second system is going to be a pulsing ring that expands anytime an enemy breaks one of our capture trails. So when an enemy collides with a capture trail, right at that point, we're going to send out like a circular ring that indicates that, oh man, damage was just dealt. And then third and finally, anytime we complete a level, we'll have a flash overlay to the screen that fades out, indicating that there's a transition from level 1 to level 2 or level 2 to level 3. So let's head to the computer screen and let's work on this lesson of game polish systems. So I have lesson 8 open here for Territory Rush in vscode.dev, our game polish lesson, but I'm going to minimize the browser because I want to open that lesson directly so I can see what I'm working with. So let's go to our Territory Rush folder, and I'm going to go to lesson number 8, and we'll open our starter file. All right, so here it is. Let's see if we have any of these systems in place. All right, so I got to destroy an enemy. Oh, I'm very bad at destroying enemies, huh? We have established that throughout the scope of these videos. Let's see. I'll try it one more time. If I can't get it, I can't get it. All right, there it is. Okay, no particles there. No particles. And you can see no rings were created when my trail was destroyed. And I'm certain if those two systems are not working, my flash overlay for a level complete is also not working. And it makes sense that all three of these visual systems are not yet working because that's what we're going to fix here in this video. So let's look at mission number 1. We've got new systems in place. Anytime we add new systems, we want to add some constants for those systems. These are our knobs, our dials that we can turn and adjust to finely tune how that system fits, plays, or looks within our game. And this is going to happen in our student edit zone. So I don't even have to search for mission 1. I know exactly where I need to go. We've got all of our system variables. Here is our ramp system. Here is our turn system, our capture goal, our enemies, our flash duration, and now we have our polish systems. We said we were going to do 3 different systems, so we have variables for 3 of them. The first one is going to be for our particle system. So when we destroy an enemy, we are going to create a bunch of particles for every enemy that we are destroying. Right now, that is set to 1. Let's get out of there. 1 particle is okay, but 20 particles is going to look great. I think 20 is a great number. You could do, you could do more if you want to, and then test to see how it looks once we get this system implemented. Now, of these 20 particles, they're all going to be different. Things are going to be very random about them. So we're going to set minimum and maximum values for how fast they move, their lifetime, so how long they are alive on the screen, and their size. And then we will randomly pick from those minimum and maximum values. So every particle is a little different. So it'll look, sporadic, almost like a firework going off. So my minimum speed, I'm going to set to 120. And my max speed, I'll set to 320. For my lifetime, the minimum life will be 0.4 seconds, and my max time will be we'll do 85 seconds. We're just picking numbers out of the air. We can always come back and adjust these. And then for my minimum size, I'll do 4, and my maximum size, I'll do 8. All right, my particle system is now set. My next visual system was going to be a circular ring that expands out anytime an enemy breaks one of our capture trails. So how long is that circular ring going to last? You can see we have trail, break, pulse, duration in seconds. Well, I don't want these to be super long because these effects should be short-lived. So I'm going to do 0.35 seconds. And then how big do I want that circular pulse to get? What is that maximum radius? So the max radius that I will take is 120. All right, so that system is set. And our final system was going to be a flash to the screen indicating that a round has been completed, that we are moving to a new round. We have to figure out how long do we want to flash. So that duration, this round clear tint duration in seconds, we want it to be quick again. So I'm going to keep it at that 0.35 seconds because it seems like all those quick visual effects, I'm keeping it, that same time. We'll keep that consistency. All right, so our constants are set here in mission number 1. Let's go see what else we got to work with in these new systems. So for my color palettes, it looks like I don't have any new color in my color palettes. All right, so I'm thinking the particles that we are going to create when we destroy an enemy are probably going to be the enemy colors. That kind of makes sense, right? We destroyed an enemy, so we'll shoot particles out of their core color or their enemy color. And let's look at our gameplay variables. So what new variables do we have to work with? All right, so right here, I have a brand new container, a brand new array to hold all of the particles on the screen. So that's going to help us because every time I destroy an enemy, I'm going to put 20 particles in that container. And what if I destroyed 2 enemies at once? Well, now there's 40 particles in that container. So we need a place to store those. And now we have it. We also are keeping track of some variables here for our trail break. We have a timer in seconds. It's currently set to 0. And when an enemy breaks our trail, we'll set this to I think we set it to like 0.35, right? And that means show that circle, right? Make that circle appear and make it grow bigger and bigger and bigger. For how long? Well, we'll keep showing it until this gets down to, we'll count it down 3, 2, 1. And once it hits 0, we'll stop showing it. So we've sort of seen this before with like our capture flash timer seconds. So we're going to use the exact same idea here. But we're also going to create variables for the column in the row that trail break occurred in. So if I'm like, right here, an enemy breaks my trail, they collide with the trail right here, we're going to keep track of what column we're in and what row we're in, because this is where we want to start or originate that pulse as it moves out in all directions. And then lastly, for our round clear system, we have another timer. So we can set this, and then once it counts down to 0, we'll stop showing it. All right, so with that system, all of those systems introduced, let's go to mission number 2. Mission number 2. Interesting. We've sort of followed this same structure here for the past couple of videos. Mission 1, add system constants. Mission 2, reset those systems when you start a brand new game. And we got to do the exact same thing here. We have to reset all of those variables that we just looked at for our polish systems, our game polish systems. So we're going to reset our particle array. Let's start right there. If we died and there were a bunch of particles currently on the screen, when we start a new game, those particles should no longer appear. So we're going to take our array, our container particles, and we'll empty it out. We'll just make it a brand new array. We should also make sure that, we're not showing anything for our trail. So I'm going to take trail break, what was it? Pulse timer seconds. I think it's going to, nope, I got the wrong one. Trail break pulse timer seconds. So let's see, if you don't want to type all that out, it's trail, and it's going to be this third one. So type trail and then tab for autocomplete. We're going to set that to 0. Let's also set trail break pulse column, our first one, equal to 0. And then let's also set the row to 0. So trail, and this is going to be now our second one here in the list. Tab for autocomplete is equal to 0. So we're resetting all of those systems. And then what was our last? I got to go back and check it because I forget what was our. Let's just for consistency, let's set round clear tint timer seconds to 0 too. I don't think that's going to have to happen. We're not going to die as we I guess we could die right when we completed a round. Let's cover all bases here. We'll set round clear tint timer seconds is equal to 0 as well, just to be safe. Okay, so now our systems are primed to reset when we begin our game. So let's head to mission number 3. Mission number 3 says we are going to generate particle data for our enemy destruction. So let's go take a look. Particles are objects, just like our enemies. We introduced enemies into our game. We had 3 functions to help with that. We generated our enemy data, we spawned our enemy, and we updated our enemies. And we're going to do similar things here with our particles. We'll generate our particle data, we will spawn our particle, and we will update our particles. Mission 3 finds us in the generate particle data function. We are asked to generate particle data when enemies are destroyed. Assign velocity, lifetime, and size for each particle. All right, so if we look, in here, we are returning an object. So we're getting an object out of this function, and that object represents a single particle. It has properties x, y, vx, vy, life, max life, and size. And they are already set for us. It looks like when we generate a particle, we're going to pass in an x value and a y value. So imagine if I destroyed an enemy right there, we're going to generate particles, and we're going to pass in that x and that y value. That's going to be the origin or starting point for our particles. So we're using the x, y values that we passed in to set the x and y properties. We're going to set the vx, or horizontal velocity, and the vy, the vertical velocity, using some nice trig functions like sine and cosine. But we have to figure out what speed they need to move at, because it's currently set to 0. This also needs an angle, and our angle is set to 0. Okay, well, that's not good. And then we're going to have a lifetime, and we're going to track their lifetime. Remember, they might live for only like 0.4 seconds or like 0.85 seconds. So we're going to store their max life, and then what their current life is, and it's this value that we will decrease over time. And once this value hits 0, maybe they are at like 0 out of 0.8 seconds, then it's time to get rid of them. And then we'll also store their size, which is also set to 0. So we got a bit of work to do in setting up our particles. It looks like we've got 4 things that we have to we got to set. So the first thing let's do is let's get an angle. So what do we want our angle to be? Well, these angles are not in degrees. Now you might say, okay, degrees, if you have a circle, you could be anywhere from 0 to 360 degrees, right? But we are using radians. And so radians are going to go from 0 to 2 pi. So 2 times 3.14. So we need to randomly select an angle, from 0 to 2 pi. And 2 pi is such a big thing here, right? In radians, it means one full circle, 360 degrees, that it's a constant. So we can just type out 2 pi. And now we will randomly select an angle. And that angle is going to determine the direction that we move off in for our particle. But we got to move off in a direction with some speed. So we now need to randomly select a speed. And we had 2 values in our particle system constants. We had particle speed min. It's going to be that second one. And then we had particle speed max. It's going to be the first one. So now we'll randomize our speed. Hey, we're going to do the exact same thing for life. If you recall, we had 2 constants in our system that randomized how long the particle was going to live for. So we'll do random particle life min, our second one. And then we'll do particle life max, our first one. Awesome. Hey, rinse and repeat. We did it here. We did it here. Let's do it one more time for size, because we had 2 constants in our system to randomly size our particles. So we'll do random particle size min, our second particle size thing here that shows up in our autocomplete list, and particle size max. Awesome. So now all of these values in our variables are set, and we create our particle. That thing is going to get returned. So when we call spawn particles in our array that we saw, our container of all of our particles, we are pushing whatever is returned from generate particle data. What's getting returned is this object right here representing a particle. Let's see if this works. So let's see if I can destroy an enemy first. I know I'm pretty bad at it. Didn't get one there. Didn't get one there. We're gonna I'm gonna get this one. Nope, it got me. Sugar. Maybe I'm gonna get this one. Let's see. Nope. Oh, this is comically bad. I swear, when I'm not on a live video, trying to do this, I'm better at this. All right, I got that one. Look at that. Ooh, so we got particles, and they sort of moved. They were different sizes. They moved at different speeds. Look at this one. It's moving super slow. But they only moved horizontally. They moved like just in a line, which is weird. And this one is never going away, so I don't really like that. Interesting. Let's see if I can get one more. Well, I lost. All right, well, we know that something's not working. So let's go to mission number 4 and see if we can fix this. All right, mission number 4 finds us in update particles. Yeah, here we go. We gotta update the particle better. So if you notice here, we're looping through our particles array, and we're using that backwards looping technique that we looked at with our enemies. We're looping at the end of the array, length -1, and then we're grabbing the particle that is at the end of the array. You do this anytime you want to potentially remove something from an array. So we're going to want to remove these particles eventually. But the first thing here, it says move the particles with each frame and then decrease their lifetime. All right, remove particles when their lifetime reaches 0. So if you look here, we have motion for our horizontal movement. Our particle's x position is getting updated by taking our particle's horizontal velocity and multiplying by dt, that time interval that we have to move. Well, we got to do something similar in the y direction now. So let's do particle.y. We're going to update our y position. It's going to equal the particle's Vy, vertical velocity, times the time interval we have to move. And then if you look, we're asking a question. It says, if the particle's life property is less than or equal to 0, we are going to get rid of it from the array. Well, we're not decreasing the life property yet at all, so we should probably do that. Remember, that life property is like a time interval. It was like 0.8 seconds, 0.6 seconds. So let's do particle.life minus equals dt to subtract that. Now, I think our particle system should be in place. All we got to do is get someone who can play the game correctly to destroy an enemy. There we go. Look at that. That looked great. That was quite rewarding to be able to destroy an enemy like that. There's another one. Oh, I'm 2 for 2. All right, so I'm very happy with that particle system. But now let's move on to our next visual system. Our next visual system is going to be our trail breaks. So mission 5 says we got to trigger a trail break. It says trigger a pulse effect when the player's trail is actually broken. Store the grid position where the break occurs. So this finds us in a function, check enemy trail collision. If you remember, we did these nice rectangular collision checks. We got the left, right, top, and bottom of an enemy, and then we got the left, right, top, and bottom of a cell that is in our capture trail, and we checked to see if they overlapped. If they overlapped, we just reset the player. That's all we did. We said, oh, your run's done. Go back to the center of your safe zone. But now what we're going to do is we're going to trigger a trail break pulse. The way we do that is with our trail break pulse. Let's see, timer seconds, that last option in autocomplete. So if you type trail, and then you go to the third trail break pulse right here, tab for autocomplete. Because that timer is currently set to 0. Let's make it not 0. We are going to set it to the constant that we have, trail break pulse duration seconds. That's our first option in that list. If you type trail in all capital letters, so I'll do that again. Trail, all capital letters, it's that first option right there. So now we've just set our timer to be 0.35 seconds. Which is great. But we also want to store the grid position where that break occurred. So if you remember, we had a couple of variables. Trail break, let's see, trail break pulse column is going to be our first option right here in the autocomplete. We are going to set it equal to, our trail cell column. So this is the one that we overlapped with. We're going to say, hey, for the trail cell that we're on, trail cell, we're going to grab your column property. And then we'll do something similar for our row. So we'll do trail break pulse row is equal to trail row or trail cell, and we'll grab that cell's row property. Now we know not only do we have to create the pulse, but we know where to create the pulse. We're going to create it at that particular cell's row and column. So right now, I think if we run this, I don't know if, let's see, I'm going to have them break. Can I get them to break my, yeah. So you see, they broke my trail. We now know where that break occurs, but we're just not doing anything with that information yet. So let's head to mission 6, and let's actually do something with that information. Mission 6 asks us to draw the pulse break. All right, so it looks like we get, let's see, we have pulse progress is equal to 1 minus trail break pulse timer seconds over trail break pulse duration. All right, so let's look at that really quick. I'll bring up a calculator right here. So when we first start this, right, trail break pulse timer seconds, we just set it to be 0.35. This is 0.35, so 0.35 divided by 0.35 is 1. 1 minus 1 is 0. So this value starts at 0. And then let's just say, it's like this is going to count down. So instead of being at like 0.35, let's say it's at 0.25 divided by 0.35. So that's 0.7, 1 minus 0.7. Okay, so it's not 0 anymore. This variable is going to be now 0.3. And then let's keep going. What if it gets to like 0.1? Okay, so 0.1 divided by 0.35 is 0.28. So 1 minus 0.28. So now that variable is 0.72. And what about when this trail break pulse timer gets to 0? So 0 divided by 0.35 is, of course, 0. 1 minus 0 is 1. So it looks like this variable goes from 0 to 1. 0 to 1. 0 to 1. This is a ramp. Oh my gosh, it's a ramp value. And we can use a ramp value to do linear interpolation. And that's exactly what we're going to do here for our pulse radius. We are going to linearly interpolate the size of the pulse radius. So let's just take a look at the whiteboard here very quickly here. I am going to start by having a very small radius. We'll start off. We don't want to start with a radius of 0. So I'll start with like a radius of, say, 10, right? So I'll say, all right, there's a radius of 10. And then we're going to go, and the radius is going to get bigger. And then the radius is going to get bigger. And then the radius is going to get bigger, even bigger. Now, how are we going to determine the size of that radius? Well, we're going to draw, and let me see if I can zoom this out a bit. Yeah, there we go. We're going to draw a graph. So let's draw a graph. And we'll have our ramp, so 0 to 1. We just looked at that. That's our ramp. And then we're going to have a starting value of, we'll say 10, and an ending value of our max radius, right? Max radius, whatever we set that to. Well, we know our starting value. We know our ending value. All we need to do is linearly interpolate between them. So when our ramp hits, some value like this, like 0.75, we can go over and read how big our radius needs to be. So this emulates or is exactly like what we did with our difficulty ramp. So let's do this right here. Let's perform linear interpolation, LERP. We're going to set our starting value, 10. We're going to send our ending value, which is a constant of this system. It is trail break pulse radius max. So that is the second value when you start typing trail, it's right here, second one down, trail break pulse radius max. And then we have to provide our ramp value, our value from 0 to 1. It is called pulse progress. Wonderful. And with that, we are now going to draw our circle of a given radius. If you look, we say no fill. I'm putting no paint in my paint bucket. And then we grab a marker that is of our enemy's color. So this is, we don't want an invisible marker. We want a marker of a specific color, and we're going to make it a little thicker. So we give it a weight of 2, and we draw a circle at pulse X, pulse Y, and those use our column number and row number that we broke our pulse in. And then our pulse size, the diameter here, is the radius times 2, and it's this value that is going to change. It's going to get bigger and bigger and bigger as we linearly interpolate. So let's check that out. Let's see if we have this system working. Come break my pulse. Let's see. Oh, that did not work. Did you see? Where did the pulse get? The pulse got generated all the way over here in the corner. So something is broken. Let's see if we can figure it out. Ah, yeah, I figured it out. Pulse X and pulse Y, those are pixel values, right? We got to say exactly where we are going to draw the center of our circle in the X and Y direction, but these are column numbers and row numbers. So we might say column 5, row 2. Column 5, row 2 would be here, but that's going to be 5 pixels in, 2 pixels down. So we actually now have to figure out what are the pixel values of these. So the way we're going to do that is we're going to take our column number and we'll multiply it by our cell size variable. And then we're also going to add cell size divided by 2 to put it right in the center of that cell, because this would give us the left, and now we'll add half of the cell width. And then we're going to do something similar here with our rows. We're going to multiply the row number by cell size, and that's going to give us our actual pixel position, but then we're going to add cell size over 2 to move us down half the cell to put us in the center. So now let's refresh that and let's see if this fixes that weird behavior. Oh, and right there we had that perfect. Let's check it again. Perfect. So I'm very happy with how that pulse system is now working. All right, so we have one visual system left to add here, and that is our round clear effect. So when we defeat or beat a round, we should flash an overlay to the screen. So let's go look at mission number 7. Mission number 7 says we want to trigger that round clear tint whenever a capture goal is reached. All right, so mission 7 finds us in draw scene, and it looks like it's right here down with our overlays. All right, so trigger a screen tint when the player completes a round. Start a timer when the capture goal is reached. All right, so if we look, hey, look here. We draw our trail break pulse whenever that trail break pulse timer is greater than 0. So we ask that question. If that timer is greater than 0, we're drawing our trail break pulse. I bet we probably should ask like a similar question. So if, what was the timer for this system called? Oh, it was called round clear tint timer seconds. So we'll use tab for autocomplete, and we're going to check to see if it is greater than 0. Well, then we want to just call some function that's going to draw our round clear tint. Let's go see what that function is going to be called. So here are all my draw functions. Okay, capture bar, ramp readout, draw trail break pulse. Now we've got draw round clear tint. So I think that's the one we want to call. So let's go back to mission 7 and let's make sure we call draw round clear tint. Draw round clear tint. We'll write the name of the function, a set of parentheses to call it, and then a semicolon for good JavaScript. So now we'll check to see whenever that timer is greater than 0, that means we're calling this function. So let's go to that function because I just saw mission number 8 appearing here in that function. So what exactly are we doing when we call this? Well, if you think about it, we probably want to draw like an overlay over the whole game window that flashes and then fades, okay? So like it's like a success. So right here we say no stroke. So we're going to get an invisible marker, and then we have a variable called tint alpha. It's currently set to 1. And it looks like we're getting a white color, so 255, 255, 255, so that's white, with an alpha of 1, which means you can't see behind it at all, and then we're just drawing a giant rectangle over the screen. One of the ways we can test this system is if we just come up to our capture goal percent. So this is on line 61 for me. I'm going to change it from 80 to like 20 for right now. So now if I run this, I only got to capture 20% of my game grid. Let's see that flash. There was no flash there at all. I did not see any flash. Did you? Okay, I think I know what our issue is. We have to go back to mission 2. I apologize for this. If we go back to mission 2 here, when we reset our polish variables, every time we reset a round, we're setting our timer immediately to 0. So we set it to 0.35 seconds, and then we reset our round and it goes back to 0. So we have to delete this line. This is on line 274 for me. That is not something that we need to do here. So now if we delete that from reset round, let's go test and see what is going to happen now. So now when I run this, get a bunch of territory. Oh, not enough. Ready? Still nothing. Why not? Well, let's go back to mission 8. I think the problem is our tint alpha is currently set to 1. Here, when we define color this way, the alpha is actually, this is not an RGB alpha string. We're just defining our paint color directly in the fill function. Alpha needs to be between 0 and 255. So let's make it 255. Let's see what happens if I do this now. So now I'm very hopeful that this is going to work. Whoa, and there it was. Not the extent of the flash that I wanted, but at least we flashed something. So the thing is, I don't want that tint alpha to be 255. That's way too high. So let's set it to like 120, but then I want to reduce it every time we call this. So the way I'm going to reduce 120 is by multiplying by some fraction. We'll start it at a value of 1, and then we'll make it get smaller and smaller and smaller all the way till it reaches 0, and then the alpha will be completely transparent. And the way we're going to do that is we'll look at our round clear tint timer seconds. So that's our timer that's going to get triggered to 0.35, and then we'll lower it and lower and lower it. and we're going to divide it by our starting value here of round clear timer duration seconds. So now that we have that, our alpha is going to start at 120, which is going to be in that nice middle range. It's not 1, it's not 255, and then we'll slowly reduce the alpha. And with that, I believe our whole game is complete. So let's check this out. Let's see that system in action. So we'll come over here. I'll grab more than I need. And there is my flash. And that flash looks so much better than that blinding white that we had previously seen. And all of our effects, our visual polish effects, are coming to play nicely there. So a couple final things we're going to do. I'm going to set my capture territory back to 80%, and I'm going to get rid of this ramp because that ramp is only really there for debugging purposes. So I don't need it anymore. So I'm going to keep the function because we may want to debug sometime. So we're going to keep that function here. But let's just go up to our draw HUD function. So this finds me on line 733. I am just going to comment that line out. So 2 slashes, comment that line out, and I can just bring it back in if I want to, and now that ramp is gone. Perfect. And so our last little fix here, I got to go back up to my student edit zone, line 61 for me. You can just click over here. I'm going to change my capture goal percent back to 80%, and I'll save that. And when we refresh our game, we have our final version of Territory Rush. Awesome. So I think this is a great place to stop here. We did a lot of great work taking our starting game in lesson 1, which was, I don't even think it was playable at all. It was just broken all over. And through 8 lessons, bringing it to this final version of a game that's challenging, fun, and really makes you think about when you want to leave your safe zone to go out and capture territory, try to destroy enemies, and move from level to level to level. So I think this is a great place to stop, and I'll see you in the next video.